This is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 6-1 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to identify the key features of exponential functions. Now remember, when we say an exponential function, we mean some kind of function in which the x is part of an exponent. Alright, so we have some number raised to an exponent. So let's go ahead and begin. A lot of this you probably already know because we've covered this in Savvas several times now. Okay? Now remember, the domain of a function is all of the potential x values that could be plugged into that function. So if I take a look at this graph, I could see that this graph continues forever towards negative infinity and forever towards positive infinity, although it's kind of going up and out, right? So the domain of this function is from negative infinity to positive infinity. Or all real numbers is another way to say that. And that domain is the same for pretty much every exponential function unless it has been rotated, unless it's been rotated or reflected across y equals x. Anyway, let's go ahead and let's take a look at the next one. Now the range in this case, you could see that the graph continues going up towards positive infinity for forever. But the range is where kids tend to struggle because they look at it and as it comes to the left it seems like it's going down. But these graphs tend to actually flatten out. Okay, and they run almost parallel to the x-axis. We'll talk about that in a moment. So our range in this case actually starts at 0, non-inclusive, and goes up towards infinity. So I would write the range like this. Or they might ask you to write it as an inequality, and so I would say y is greater than 0. Alrighty, so now let's talk about the fact that this graph kind of flattens out. What ends up happening is you get something called an asymptote down here. Alright, an asymptote is almost like a force field for a graph. So what ends up happening is this graph gets closer and closer and closer to that force field, but it never actually touches it. Alright, this asymptote is at the line y equals 0. So remember, it has to be the equation of a line when you write an asymptote. You can't just write 0 because it could be a vertical line that you're describing. Okay? But what that means by having an asymptote at y equals 0, that means that there's no x-intercept because it's getting closer and closer to that x-axis but never actually touching it. Now this graph does have a very clear y-intercept. In fact, it has its y-intercept is our main anchor point that I deal with. Okay, now that y-intercept is at the ordered pair 0, 1. But for some reason, Savvas usually just asks for the number 1, the y value. So just kind of keep your eyes out. Understand that it's the number 1, but really we're talking about the ordered pair 0, 1. And if I remember correctly, I think Savvas also kind of goes back and forth on that. And they go between writing it as an ordered pair and writing it as a number as well. Alright, and then we get to end behavior. So there's kind of two sentences that we write with end behavior. Alright, so I'm just kind of writing those sentences out right now, and then I will go through and tell you how to read them. Now notice the only difference between these two sentences is the negative infinity and the positive infinity, okay? So this little arrow, remember, is the word approaching or approaches. So as x approaches negative infinity, so all that means is as x is going to the left towards negative infinity, y approaches. So what is y getting close to? In this case, y is approaching this asymptote, right? So I would say y is approaching 0. Now if I read my second sentence, as x is approaching positive infinity, so as x is coming to the right, y is approaching, and if you look at our graph, this graph is going up and up and up and up for forever. So what does that mean? That means that our y is approaching positive infinity. All right, so let's go ahead and let's try this middle one. So again, I told you the domain on these is pretty much the same every time, unless you're dealing with like a word problem that restricts the domain. All right, so this graph goes forever towards negative infinity. It's going up faster, but it is going towards negative infinity. And it goes for forever to the right towards positive infinity. So our domain here is negative infinity to positive infinity, or all real numbers. Our range in this case is the same range because it goes for forever towards positive infinity in the y direction, but our graph again becomes asymptotic at y equals 0. So for our range, I would say it goes from 0 to infinity, or I'd say y is greater than 0, depending on what they ask us to do in our problem. And I said it just a second ago, there is that asymptote, that horizontal asymptote at y equals 0. And of course what that's doing is that's affecting our x-intercept. It's causing us to not have one. Now our y-intercept in this case is at a very friendly 5. I'm just making that number bigger so you could see it. So I'd say the y-intercept is at 5, or at the ordered pair 0, 5. And we'll talk about that y-intercept here in just a second. And then our end behavior sentence starters. Alrighty, so now we're going to look in the directions that they're traveling, right? So as x is approaching negative infinity, so as I'm coming to the left, where's y going? Well, y is going up and out for forever, so y is approaching positive infinity. And as x is approaching positive infinity, so as we're going to the right, you can see that y here is approaching 0, which is our asymptote. Alright, so now this third one I believe is the try it. I'm going to write the word try it here to remind you. So our domain is again the same. Our range in this case is also the same, right? Because we have that asymptote at y equals 0. Now the range of all of these isn't always going to be the same because we might have, we're going to get into translations here in a minute. And so if we translate this down or up, it's going to affect that range, right? So understand that range is not always the same. Neither is the fact that there's no x-intercept here. If the graph is translated down, you'll have an x-intercept. Or if the graph's translated up and reflected down, you'll also have an x-intercept. So just be aware, those are things. However, with this type of graph, you'll only have one x-intercept at a time, which is kind of interesting. Now our y-intercept is right here. Sorry, it's a little hard to read the Desmos graph, isn't it? But that's at the point 0.04. And our asymptote, again in this case, is the x-axis. I kind of wish they would have switched it up a little bit on the graph so that we could see some differences, but I think that you guys are kind of getting the point here. Alright, so there's our sentence starters for our end behavior. So as x is going to negative infinity, so as we are going to the left, you can see on this one the graph is going up towards positive infinity. And as x approaches positive infinity, so as we go to the right, y is approaching 0. Alrighty, so there we have it. That is identifying some of the key features for exponential functions. Until next time.